standing to the side.
You have to do it anywhere you like.
Why do you have rules if someone's trying to kill you? But what if someone's trying to kill you? Have you ever been trying to get killed?
We're not gonna do template. We're gonna do a little different. We're gonna do like notes. So there's 3 different types of chi-square tests. 2 of them are basically identical. But I'm just gonna go through like how you know which to use, when to use which. We're gonna like summarize it. And then if you guys want a template, we can do a template. I don't know if you'll need one, but we'll figure it out. So we started with chi-square goodness of fit. That's one list, one category. Degrees of freedom is categories minus 1. And you would have, I'll do like the HO and the HA for each one. So HO would be, I think we worded it a little different on the template, but something like each proportion of blah, blah, blah is as claimed. And then HA would be at least one proportion different. And for this one we had like, you'd have one row of data, and if you remember we put like the observed here, the expected there, then we put the observed in L1, the expected in L2, and you run the test. So you know it's that, like you don't even really need to worry about categories. You know it's that one if there's just like one list or one column. As soon as it gets into a 2-by or 3-by whatever grid or table, it's going to be the chi-squared test, which applies to actually 2 different things. And then the categoric or the conditions for all of them are the same, like the IRL thing we were doing, the conclusion's the same. Yeah, all right. So then we did, yesterday we did, I keep forgetting, we did independence, right? Okay, so chi-squared independence. This is going to be one sample. Two categories. Like yesterday we had like yes or no and male or female. That was all one group. We just had 2 things going on with that group. So HO here would be, it's like category 1 and category 2 are independent. Or what else could you have said instead of independent? Not associated. And then HA is the same thing, but it'd be are not independent or associated. Then this is the one where we use the matrix. So you put your observed in matrix A. And then you run the test, and the calculator will put expected in matrix B. Degrees of freedom for this one, what was it? Rows minus 1 times columns minus 1. The expected value per cell, so I'll write expected value in any one slot. Remember that? I think that's what you were saying. Yeah, rows times columns divided by number. This is totally unrelated, but when I was a kid, my favorite pop was RC Cola. Does that exist?
Yeah.
It does? Okay. And then the third one, and here's like me teaching you, I'm going to teach you the new one in this amount of space right here. So the third one is chi-squared for homogeneity. Homogeneity. Is that how you used it in biology, if it was like homogeneous or not? So this will be multiple samples, one category. So HO would be that category 1 and category 2 are homogeneous, which means they're distributed the same. I'll go through what that means in a second if that's not clear, because it's probably not. And then HA would be that category 1 and, wait, this is a lie. I have contradicted myself on my own paper here. What did I do? I said there's one category and then I put category 1, sorry, this should be sample 1. My bad. This was gonna be such a nice sheet of notes too, and now it's ruined. Sample 1 and sample 2 are homogeneous. And then sample 1 and sample 2 are not homogeneous. So we'll do one, just so you can see it's the same. And then all of this stuff here is the exact same. Like the mechanics of doing the test are identical. It's just like how you're declaring what you're looking for. And whether you have like one sample or two. But the way you run the test in the calculator, like you guys saw, there's the chi-squared GOF, then there's the chi-squared. There weren't like 3 different tests in the calculator, there were just 2. So there's the GOF, and then this is, either one of these is just like chi-squared. So let's do a homogeneity one. So flip it over. I'm gonna do AP Stats and AP Calc, AP Scores. So with the GOF one, we did one where I said like, the AP test says 20% in each category. We're taking our one sample and seeing if it fits with what they said. This, I don't care what they said. I'm trying to see if they're the same as each other. So it doesn't matter what the AP test said. It's more like, I teach AP Stats, I teach AP Calc. Are my students getting like the same scores, or are they way better in one or way better in the other? So you're not comparing to some like given thing, you're comparing to each other. So let me put some numbers in here. distributed the same? Well, 15s are the same. The 10 and the 15, but then this 20 kind of throws things off. So I don't know. Looks like kind of, but let's see. But so what we have here is two samples, right? The stats group and the calc group, and one category. And the category is just like your AP score. So we're going to do chi-squared for homogeneity. But like which one you do is only determined by.
I'm not quite sure how to help you with that.
I didn't say anything. Yeah. I could give you that same table and I would say, are AP stats and AP calc independent? And then you would do chi-squared for independence. Or I would say, are AP stats and AP calc homogeneous? And then you would do homogeneity. Like it just depends on the wording. You're doing the exact same process. And you'll see when we do like multiple choice examples, you'll see how you can tell, or in the con, you'll see. Okay, so HO is going to be AP Calc and AP Stats. R distributed the same, or you can put R homogeneous. That's that thing, like you don't ever really have to remember the vocabulary word. You don't remember the vocabulary word. Homogeneous, just write out what it means, distributed the same. So that HA would be AP Calc and AP Stats are not homogeneous or are not distributed the same, or if you want to get really fancy, you can say heterogeneous. Bless you. Let's say alpha is 0.05. That's like our intro. So we got our conditions, which is the IRL thing, right? So I for independence. So what do we got? 30, 50, and 60. Right? 80 and 75. 80 is less than or equal to 10% of all stats. And 75 is less than or equal to 10% of all calc. Because you have two samples there. We didn't have to do that in the previous problem, the independence one, because we only had one sample. So R is for randomness. So we say like assume SRS, because that doesn't really tell you. And then L is for large counts. So each expected cell, not the observed one. Each expected cell greater than or equal to 5. Alright, then I'm going to make my big table. I'm going to put stats, calc, 1, 2, 3, 4, 5. And I'm going to tell the person grading it what I'm doing. So I'll put the observed and then the expected value in parentheses. I'm also going to tell them that I know the expected value, even though I'm not going to use this formula, the calculator's going to do it. I'm going to tell them I know the formula for the expected values is rows times columns divided by n. Bless you. And then I'm going to put in the observed. expected is like, if these were independent, what would we get? And then we see how far away from that we are to see if we are going to reject or not. Still waiting. So remember we used the matrix? So it's the, matrix is the x to the -1 button, but it's like the shift. So you hit second and then exit to the negative first. We're gonna edit matrix A, run through the calculations, and it's gonna pop out and tell us what matrix B is. So matrix A is not a 3x2 anymore. It is a 2x5, good. And if you get it wrong, like if you got confused and you're like, I don't know if it's 2x5 or 5x2, if you type 5x2, like you can see that doesn't look the same. So then hopefully you'd be like, oh wait, yeah, it's 2x5. 2x5 is a little annoying because you can't see the whole thing at once, which is kind of harder to type in, but it's not that bad. There's a little thing at the bottom, you see where it says like 2, 1. That's like second row, first slot. Then as you hit enter, it does keep track for you like where you are. So now I'm in the second row, third slot. Sometimes that's helpful to look at. The phone app still do this. Yeah.
And I can see that matrix.
Also it's better. Alright, so now exit out. And then go stat tests. So like I was saying, there's only two. The GOF is what we did the first day, that's when you only have like one list. And either of the other two, whether it's homogeneity or independence, you're doing just the regular chi-squared. And it's saying to you, hey, where did you put the observed? I put it in A. It's saying, where do you want me to put the expected? I want it in B. I also want you to tell me chi-squared and the p-value. Degrees of freedom. You guys get what I'm getting? So, I have to go back to the matrix, right? So I gotta go second matrix again. And I'm gonna edit matrix B. I'm not actually gonna edit it, I'm just looking at it. And I'm gonna write down those values in the parentheses in my table. You gotta kind of scroll across. Remember, if you were doing it for real, so very often on the multiple choice, it would, instead of asking you to do the whole process, it'll say something like, what is the expected value for 3s in AP statistics? There's two ways you can get to that. One would be to enter in all of the data into matrix A, have it run the test for you, go look at matrix B and see what's in that slot. Some people are like, I don't want to type in the whole matrix, that takes too long. So what you could do then, you could also use this formula. So if I wanted that slot, I'll take the total in this row, times the total in this row, and divide it by the total of the whole thing, and that would also give you that number. So you've got kind of a choice there. So they gave me, I should have written these down, I gotta run my test again. So the chi-squared value, I'm gonna write the formula. And then they gave me the value is 2.54. I know the p-value because I'm looking at it, but I'm gonna pretend I don't. Let's say chi-squared CDF. Remember with chi-squared, it's always doing, that's a 2 by 5, right? So you subtract 1 from each of those values, so it's 1 times 4, and that's how they got 4 for degrees of freedom. The p-value is 0.37. So like, if I had done anything different than yesterday except for the HO and HA, no, it's the exact same thing, right? Make my little graph down here, chi-squared, shading to the right, that's my p-value. And then we conclude. So the p-value is bigger than alpha. Since p-value greater than alpha. We failed to reject HO, so we think these are distributed like pretty much the same. We're not proving it's identical, but we're pretty sure. Fail to reject HO. Test is not statistically significant. We do not suspect HA is true. So again, the only difference is the wording at the top. I mean, it is like a different sample and category thing, but I don't even really ever think about that when I'm doing them. Like, I'm not ever reading through a problem going, okay, how many categories, how many samples? Like, that's not how you really would typically think about it. It'll just be the wording. It'll basically either say tell me if they're distributed the same or not, or it'll say tell me if they're independent or associated, one of those things. And that's what, like, the COD will give you a lot of practice on that. We'll do multiple choice practice on Monday. Like the AP multiple choice practice that we do. And then when I got up there, I'm thinking practice test Wednesday, so I'll give you practice test, and then test Friday. So if you're a senior, like, that's way extra plenty of time. If you're a junior, I'm thinking like, do this in class on Monday, but then you don't have to think about it. Tuesday you take your SAT. Wednesday you'll be here, you do the practice test. Thursday you don't really care about your test, right? Like, you're not stressed about Thursday, I'm assuming. Is that a fair statement for juniors? Any junior, nod your head up or down, or yes, are you stressed about Thursday? About the work keys?
Yeah, because I don't know what they are. Don't be stressed.
Oh.
I still don't
Okay.
know what they are.
Let me rephrase
I still
this.
don't know what that was.
Be stressed about Tuesday. Don't be at all stressed about Wednesday or Thursday. So instead of asking, I'll just tell you how to be stressed. Stress for Tuesday, that's it. So then I think test Friday is okay, because Thursday, like Wednesday, Thursday are not stressful things. Like, you have to do it, but it's not like it impacts your future, or it really has, like, you're not studying for it.
They're like a workplace readiness.
So the MME is for the state of Michigan to assess how our school is doing. And the work keys, they say it's for, like, employees use it, employers use it to, like, see if you're ready for the workplace. But I don't think that's,
Because they see that.
I don't think any work, does anybody have a job that they ask you to see your work keys for?
No. I have a
Exactly.
job right now. I have to take it.
This is what I'm saying. So, this is why you don't stress about Thursdays.
It's just like random questions.
Like, from what I've heard, it's like crazy easy.
It's
And
so
then the
easy.
last two were like, holy crap, I have no idea. Or was it just like crazy easy?
I was like crazy easy.
I
don't even remember what was on there.
I listened to like the practice one, and it was like basic kindergarten math, and I was like, I don't know why I got attending.
So I think, my point is for juniors, I think Friday is fine for the test. If you get to that week and you're like, I'm feeling overwhelmed, I'm taking Monday So, I was gonna give you time to work on your con, and I was gonna use this time to also remind you, you noticed, I mentioned this yesterday as well, I'd say like half your freaking test last time, I just pulled directly from con. So again, those of you that aren't doing it are screwing yourselves twice. One, because you don't get the curve. Two, because you're not seeing some of the problems that will literally be on the test. So I would use this to work on your con. You want the top part? You don't even need me anymore? Sure? What?
You say, see my finger, see my fingers, see my thumb, see my fist, you better.
We're in it together.
That's what
Oh, you're taking the test today, right?
Yeah.
Yeah, where are you looking? Did you talk to her about it? Like, is it okay that you missed class? I thought you had like a free hour.
No, but it is a 3 hour. I'm already done with work in my class. Sorry, my
You're sure it's not going to how it is?
I can ask him.
Yeah, double check.
Carmen and stuff. He's gonna be annoyed either way. He doesn't like me very much.
Why?
I slept through his entire class in 8th grade
Yeah, I got you.
because they put me on defense and made me exhausted and just so bad. He just,
I got you. That's no worries.
he also doesn't like my mom. They knew me from high school.
Wait, who's your mom? So she went here. Because I taught Steven. I don't remember that name though.